All right, we're back for the second part of 9.2. We'll do three parts of this. This will be the second, and we're going to put it all together for a one sample z-test for P. State the hypothesis as we do the four-step process that we want to test and the significance level, and define any parameters that we're going to use. We're going to identify the appropriate inference method and check conditions. We're going to, if the conditions are met, perform the calculation, so give the sample statistic, calculate the standardized test statistic, and find the p-value. And then we're going to make a conclusion about the hypothesis in the context of the problem. So here it is. Again, those three conditions that we talk about here. The random condition just ensures that p hat minus p naught is a good estimate for the difference between the true value of p and the null value. All right, the large counts condition, again, allows us to use the normal distribution so that we can find that z-score. And then the 10% condition allows us to use a familiar formula for the standard deviation. That's the key there, is what we use those for. All right, so the conditions are meant to perform the test of the null hypothesis that p is equal to the null proportion. Compute the standardized test statistic. Okay, so we're going to go with that formula. Very similar to what we've done before. We did confidence intervals. And so again, we're going to do this if the alternative hypothesis is that p is bigger than the null proportion, then it's going to look like this. If it's less than, if the actual true proportion is less than, it's here. And then if it's not, we're going to have two tails. What we're going to do is two-sided is what we're going to call that. Okay, so here we go. Recall that the potato chip producer we met in section 9.1 and its main supplier agree that each shipment of potatoes must meet certain quality standards. Now, if the producer finds convincing evidence that more than 80% of the potatoes in the shipment have blemishes, the truck will be sent away and they get another load. Now, otherwise, the entire truckload will be used to make potato chips. Now, the potato chip producer has just received a truckload of potatoes from the supplier. A supervisor selects a random sample of 500 potatoes from the truck. An inspection reveals that 47 out of those 500 potatoes have blemishes. Is there convincing evidence that at the 10% level, if A is 10, that more than 8% of the potatoes in the shipment have blemishes? All right, so here we go. So we got to try to think about what we're going to do here. So let's state we want to test the null hypothesis that the true proportion is 8%. And the alternative hypothesis is that we believe that proportion is bigger than 8%. P is the true proportion of potatoes in the shipment of blemishes using a significance level of 10%, 10.10. Okay, now plan, we're going to do a one sample z-test for P. We did our three checks here. That is random. The 10% condition holds. And so does our large counts condition. So we're all good to go. We're all set up. Let's do it. 47 out of 500. That is a proportion of 0.094. And when we put that in here, we subtract the proportion that we're saying is 0.08. And then we find the standard deviation of that. 0.08 times 0.92. Our sample size was 500. Again, take the square root of that. We get a z-score of 1.15, and we look on our look on the z-table and find that p-value. And again, since we're above, we got to subtract it from 1. Remember, we got to look at above, so it's 0.1251. Again, you can use your calculator as well if that's what you'd like to do. So again, 0.1251 is our p-value. So conclude. Now, because our p-value is greater then our 0.10, our significance level, well, we're going to fail to reject the null hypothesis. So we're going to say there is not convincing evidence that the true proportion of blemished potatoes in the shipment is greater than 0.08. That's our conclusion. So that's our four-step process, putting it all together. All right, now remember, when a significance test leads to fail to reject the null hypothesis decision, as in the preceding example, be sure to interpret the results as we don't have convincing evidence for the null hypothesis, or for the alternative hypothesis. Saying anything that sounds like you believe the null hypothesis is true will lead to a loss of credit. Now, again, it would be wrong to say that there is convincing evidence that the true proportion is 0.08. Don't write that. Just say we fail to reject the null hypothesis. So don't write it out. We're not doing text message stuff. Fail to reject. Don't do FTR. I know what you're saying, but that's not going to grade well. We don't, we want to be so that we're clear when we write those. Now we can use your calculator to carry out the mechanics. But there's a risk involved. If you give just the calculator answer with no work, and one or more of your values are incorrect, you'll probably get no credit for the do step. So make sure that you, kind of showing what's going on. Again, show everything that you do there. All right, let's talk about two-sided tests. Now, the p-value in a one-sided test about the proportion is the area in one tail. And it's of the number distribution of the tail specified by the alternative hypothesis. So that's if we're greater than or if we're less than. Now, if we're just saying it's not equal to that proportion, well, now we have two tails to that. Okay, so it's a two-tail test. All right, so let's go through this. According to the Centers for Disease Control, CDC, 68% of high school students have never smoked a cigarette. Yanhong wonders whether this national result holds true in her large urban high school. Now, for her AP Stats project, Yanhong surveys a simple random sample of 150 students from her school. She gets responses from all 150, and 90 say that they have never smoked a cigarette. Is there convincing evidence that the CDC's claim does not hold true at Yanhong School? All right, well, let's see. Let's state, remember a four-step process. We want to test the null hypothesis that the true proportion is 0.68. Our alternative is that it's not. And P is the proportion of all students in Yanhong School who would say they never smoked a cigarette. So we're going to use a 5% significance level, so 0.8 is 0.05. All right, so plan, one sample z-test. We'll check our conditions. Yeah, it's a simple random sample, 10%. It's less than all of the kids in our school. And then our large counts conditions, those are both bigger than 10. So we've got that. Now let's do the do. 90 out of 150, that's a proportion of 0.60. So we're going to take 0.60, subtract what we suggest is the 0.68. All right, standard deviation on the bottom, 0.68 times 0.32 divided by the sample size, square root. We get a z-score of negative 2.10. And this is what they were talking about in the other slide, is that showing this work is going to get you a little more credit than just going right to the calculator on this. So I'd suggest kind of doing that. All right, so now what we're going to do is find the probability that z is less than 0.210 or it's greater than 0.210. So we find that percentage at 0.179, but because there's two tails to it, we got to double it. Okay, because it's both. It's not, so we got to use that two-sided test. So we get 0.0358. Now, because of that, all right, you use technology as well. Just make sure to multiply it by 2 when you have two tails. Now, because our value is less than our significance level of 0.05, we are going to say that we're going to reject the null hypothesis. We have convincing evidence that the proportion of all students at Yanhong School would say that they have never smoked a cigarette. It differs from the CDC's claim of 0.68, so but we reject that null hypothesis. So we're going to say, nah, that's probably not equal. It's there. So yeah, that's what we've got in that case. So good suggestion. Now, again, some AP tips here. When making that conclusion, be sure that you're describing the parameter, not the statistic, in the preceding example. It's wrong to say that we have convincing evidence that the proportion of students at Yanhong School who said they have never smoked differs from the CDC claim. We want to say the proportion who said they have never smoked is the sample portion, which is known to be 0.60. All right, so the test gives convincing evidence that the proportion of all students at Yanhong School who would say, not who actually, but who would say they have never smoked a cigarette differs from 0.68. So again, be real careful how we phrase things there. All right, now there's a link between confidence intervals and two-sided tests. A 95% confidence interval gives an approximate set of p-naughts that should not be rejected by a two-sided test at the 5% confidence level. Any p-naught value outside the interval should be rejected as implausible. It's kind of interesting. A two-sided test at significance level A and a 100, if you subtract it from 100, 100 times 1 minus A, and then, in other words, if a 95% confidence interval at a significance level of 0.05, they give similar information about the population parameter is what they do. All right, so that's going to finish this part. We'll have one more part that we'll kind of break up here in section 9.2, and until then, I'm Mr. Bone.